Hello, kicking off the 2018 MAT with the 10 multiple choice questions. Starting with question A, the area of the region bounded by the curve y equals square root x, line y equals x minus 2, and the x-axis equals what? So, well, that's going to be positive. Yeah, we only need the positive quadrant of this. So we've got our square root thing doing that. X minus 2 is doing something like this. And we want this area here, that's going through 2. And where are they intersecting? They're intersecting at, so root x is x minus 2, so x is 4, looks good on that. So that's at 4. So that area then is going to be the integral of x to the half dx between 0 and 4, and then take off this thing, which has got sine 2 and 2. Right, so that's going to be minus 2. So that is, what we're going to have, 2/3 of x to the 3 over 2. For x is 4, essentially the 0 is going to disappear, minus 2. So 4 square rooted and then cubed, so that's 8. 16 over 3 minus 2 is 10 over 3. D, fairly standard question, that one. Question B, the function y equals that satisfies that equation for what values of k? Right, oh, easy one to differentiate at least. So we can plot this in. And so we've got k squared e to the kx plus, actually, I'll be writing that out a lot. That might be worth just putting as y. Let's leave that as y. K squared y plus ky multiplied by ky minus y is equal to ky squared. So we've got y squared on both sides. Can we divide by that? Is it ever going to be 0? No, it's not. So we can divide by the y squared. That's not a solution. So we'll get k squared plus k multiplied by k minus 1 is equal to k plus 1, k minus 1 is equal to k. So we've got a solution at k is 0. That's one option. And then we've got k plus 1, k minus 1 is equal to 1. So we've got a positive quadratic in k, which is cutting the x-axis. It's got 2 roots, so it's going to have 2 solutions off of that. Whatever they may end up being, it doesn't really matter. We know that we've got that happening, so it must be cutting through the line y equals 1. So we must have this solution plus those 2. So we're getting 3 solutions for D. Yeah, that's good. And C. Let A, B, C, and D be real numbers. 2 curves have exactly 2 points of intersection when. So we've got ax squared plus c is equal to bx squared plus d. A minus bx squared is equal to, well, actually, let's leave it as plus c minus d. Put that in brackets, is equal to 0. We want 2 solutions, so we need our b squared, which is 0, minus the 4ac. So the 4ac, so we've got 4a minus b, we've got a minus, so d minus c. That has to be greater than 0. Well, we don't care about the 4 then. And, oh, it's the last one. There we go. It's dropped out. E. That's good. D. If f of x is that, what are the coordinates of the minimum of that? So we're just shifting it 2 to the right. So let's find where this is then. So 2x minus 5 is 0. X is 5 over 2. We move it 2 to the right. So we've got 9 over 2 for the x coordinate. So not that one, or that one. And then what is the y coordinate going to be? So we want to use that value of x. So we get 25 over 4 minus 25 over 2 plus 7. So 7 minus 25 over 4, so 3/4, which is B. Right, they're not doing much to test us as yet. Circle of radius 2 centered on the origin is drawn on a grid of points with integer coordinates. Let n be the number of grid points that lie within or on the circle. Right, so we've got a grid of integer points, it was saying, is it? Right, so we've got something like this going on. That's our origin. And this is radius 2. So it's going through there, 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 and there. So it's doing that. And we've got what? N is the number of grid points that lie within or on the circle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What is the smallest amount the radius needs to be increased by for there to be 2n minus 5? So we want to get to 21. So we need to add 8 points, grid points within or on the circle. So we need to add 8. So we want to add 2 in each quadrant. So we can stretch out to include that one and that one. So we want to get our radius up to, that's our radius, that's 2 by 1. So we want to go up to root 5. That's where we started. What is the smallest amount? There's only one, it looks like A, but that doesn't just say root 5. Oh, how much we have to increase it by. So we're going up from 2 to root 5. So the difference is root 5 minus 2. So it's A. Okay, that's quite a nice little question. A particle moves in the xy plane starting at the origin. Each turn, the particle can move in one of two ways. It can move 2 to the right and up 1, or 1 to the right and up 2. What's the closest the particle can come to the point 25, 75? Right, well, it's not going to be wanting to go 2 to the right and up 1 then. It's going to want to do this all the way because it can get up to 25, 50 is going to be better. Yeah, so it just wants to keep doing this. So we've got essentially y equals 2x is the line that we've got. And we want to see how close does that get to that point. So we need another line that passes through that point that's perpendicular to the line y equals 2x. So we're going to have y minus 75 is equal to minus a half of x minus 25. That's what we've got to have, isn't it? So that has then got to intersect with this at some point. So we've got a 2x in there. So 2x minus 75 is, let's just multiply everything by 2 because this is just horrible otherwise, isn't it? So let's ditch that for a bit. So 4x minus 150 is equal to minus x plus 25. So we've got 5x is 175. So we've got x then is 35 and y is 70. So we need to get the distance between these 2 points. So our distance d squared is going to be the change in x is 10. So we've got 10 squared. The change in y is 5 squared. So d is the square root of 125, which is 5 root 5, which is B. That was quite a nice question as well. So onwards to G. The parabolas with equations that and that touch at a single point, which means what? Yeah, what does that mean? So, well, we know that x squared plus c. Oh, we got to get what c is, yeah. X squared plus c is going to be equal to the square root of x. So that's one thing. And they've got the same gradient at that same point. So 2x will be equal to, so that will be a half of 1 over the square root of x. So 1 over 2 root x at the same x. So what are we then doing with this? Well, this is just going to give us a number for what x is. So we've got x to the 3 over 2 is equal to a quarter. So x is equal to 4 to the minus 2/3. right, and then we've got to put that into the top one. So c is going to be equal to, and we're square rooting that, so 4 to the minus a third. Good lord. And then we've got to take off that squared, so 4 to the minus 4 over 3. Ugh. So that, let's just write that out in a slightly better way. 1 over the cube root of 4 minus 1 over, well, 4 times the cube root of 4. Yeah, that's okay, isn't it? So that's going to be, well, let's get them over the same, make that a 4 and a 4. 3 over 4 times the cube root of 4, which is b. Right, fiddly fiddly. That was more of a surds question than a coordinate algebra type affair. H, two triangles S and T are inscribed in a circle as shown in the diagram below. The triangles have respective areas S and T. S is smaller, so S is smaller than T, right? Smallest value that can equal is what? Right, let's scroll down a bit to see what's going on. Don't really need the picture, do we? So we've got that, and we have to get some minimum value of this, but we can't really differentiate it because we got S's and T's. So we want to know, what are we trying to work out? So S and T can change around, but S has always got to be smaller than T. So let's just put them as being some multiple of each other. So if S is smaller, let's say then that T is A times S to make it bigger, where A is greater than 1. So we got that. Well, let's dump all that in here then and see what we end up getting. So we're going to get that 4s squared plus a squared s squared over 5 as squared. So all those s squareds are cancelling. So we've now got 4 plus a squared over 5a. And we want to get the smallest value of this. So we want to differentiate this. So let's do d by dA. So as a is changing, that's changing the relative areas of t and s. But we've got this constraint on what a can be. So split this into two fractions. So the 4 over 5a is going to go to minus 4 over 5a squared. And then we've got a over 5, so just plus a fifth. So we've got that, which we want to equal to 0. And if we differentiated that again, then we're going to get a positive value. So that is going to give us a minimum. So that's okay. So yeah, we've got all of that. Well, we can multiply through by the 5s. That doesn't really matter. So we've got that 4 over a squared is equal to 1. So a is plus or minus 2, but it needs to be greater than 1. So a is equal to 2, which is not any of the answers. What are we trying to work out? Oh, we want the smallest value, so we've got to put it back in again. So yeah, we need to put all this back in to get an actual number. So we've got 4 plus 4 over 10. So 8 over 10, 4 over 5. Right. Ooh, C. Just as well I didn't have an answer that was 2. I probably would have just circled that at the end. Getting so engrossed in working that out. That was a bit of a missed trick for them, maybe to catch people out. A sketch of that curve is given in which one? Ugh. Right, well, let's do the usual then. So when x is 0, that's always a good starter. So we get 0, 0, 0, 0. We've got y to the 8 is equal to 1. So when x is 0, we've got that y is plus or minus 1. So it's not A, it's not B, could be C, could be D, it's not E. Well, that's wiped out a lot of stuff. Then what are we going to do? What are the big differences between these? Are we going to be getting any numbers up here? Are we getting a huge value of y for something? Or is y going to end up being negative? So when, as x gets really big, so as x tends to infinity, what are we getting? we're getting some massive number. Yeah, okay, we got a 1 there, but we know we've got an infinity to the power of 16 is appearing, even if we ignore the y's, because we got an x to the 8 and we got to square it. So we got some enormous positive number. So we have to have something that's going to bring that down to 1. So we have to have some negatives in here somewhere. So y is going to have to be a negative number. I know we're going to have positives when you then square them, but if y is negative, these terms can bring it down. So y is going to have to be negative, and it's got to be more negative than x is positive. So we can't have d, it's going to have to be c. That was a sneaky little effort of a graph sketcher, that one. But yeah, happy with that. Right, Jay, which of the following could be a sketch of the curve px plus py equals 0 for some polynomial p? Right, px plus py equals 0. So we've got some polynomial. We've got to produce one of these things. So we could have, for argument's sake, y equals x. If we had that, well, actually, let's say p of x is probably a better way of putting it, because we got y's elsewhere, is equal to x, say. That's a polynomial. So we'd do px plus py would be equal to x plus y. X plus y is 0, so we want y equals minus x. Yeah, that works. So it could be D. Could certainly be D. Which of the following could be a... So yeah, D is a big yes. That's a tick in the box. So it can't be B as an answer. It can't be E as an answer, because they've both ruled out D. So it's got to be one of those. Right, can we get anything else then? Like, this is looking suspiciously circle-like. So what if we add p of x was x squared minus 1? Then when we add these together, we get x squared minus 1 plus y squared minus 1 is 0. So x squared plus y squared equals 2, which means we can get a circle. So it can't be A, but we've still got C and D in both of those options. So can we get either of these things? Right, how are we ruling this out? I mean, this thing is saying that we're ending up getting something that is saying y is, say, an x squared minus 1 for A. And we know we can't have B in this because they're both on this side. I mean, the question is, can we get A or not? That's the difference between these. So we don't have to worry about that. Could we get a y equals x squared minus 1? Well, no, we can't, can we? Because whatever we do to x, we're doing to y. So they have to be the same power. We can't replace one or the other. These things have to be symmetrical. Actually, I mean, that's another way we could have gone about this. Actually, we're saying with this, we have to have a line of symmetry on y equals x, because x and y are interchangeable. So we could rule out A immediately. So it can't be that one. So it's going to have to be C. It's the only option that we've got. So yeah, okay, that was an interesting end as well. That was a decent bunch of questions, I think, on that. They were all doable, but they had some fiddly bits in there. But overall, again, I think that's not a bad bunch for a start set of questions. Maybe not quite as easy as 2017 tests, but not as difficult as some of the previous ones. But they were a nice bunch. There were still some insights to make in these and different ways that you could go about them. So it's not like they were trivial.